So to solve this warm-up, if we look at this problem here on the left, the first thing we have to decide is if we are dealing with a right triangle, because the Pythagorean theorem only works with a right triangle. And so we do. We know that because there's a little box in the corner. And then I have to decide if I'm looking for a hypotenuse or a leg. And if I take my pencil and draw a line across from the right angle, it'll always point to the hypotenuse. So for the one on the left, we are looking for a leg. So the Pythagorean theorem tells me that the area of the squares on the legs will add up to the area of the square over here. So the area of this square on the left would be 8 squared. And then we would do plus 3 squared. So 8 squared is 64. 3 squared is 9. Add those together, it's 73. That gives me the area of this square over here. But I want to know what the side length is going to be. So to find the side length, when we know that the area of the square is 73, we are going to square root 73, which is going to give us approximately 8.54. So then the next problem, again, do we have a right triangle? Yes, we do, because of the square in the corner. And we need to know if we're looking for a hypotenuse or a leg. The 10 is the hypotenuse because it's across from the right angle. So that means that we're looking for a leg. So this time we're going to subtract the areas. So we would have 10 squared minus 6 squared. So 100 minus 36 is 64. Square root 64, and that's going to equal 8. You're now going to work on a worksheet that is going to walk you through some word problems. You will find that if you did the problem correctly, the answer should be at the very bottom of the page. You're going to cross out the answers that you get. The only thing that's really different about this worksheet is that the answers are rounded to 1 decimal point. It's rounded to tenths instead of hundredths, so you need to watch out for that. And then this here didn't copy well. That is an 8. It's not a 3, so watch out for that. When you are done with those 3 problems, you may move to the next slide. So this problem should be relatively easy for us to solve. It is a word problem. There's a story to it talking about a wire that's stretched from the top of an 8-foot pole. But the diagram is drawn for us. So it should be real easy for us to decide, are we looking for a hypotenuse? Are we looking for a leg? And using the Pythagorean theorem to help us. Again, make sure that you find your answer at the bottom of the page and cross it out when you are done. So number 3 can be a little bit more difficult just because it doesn't have a diagram to it. We're going to have to actually draw the diagram. So let's look at some words that might help us. Vertically, 300 meters. So when I draw that, I'm probably looking at a vertical line of 300 meters. And then it flew west. Okay, so west would be usually to the left, 400 meters. So I'm actually going to move this 300 over here, and I'm looking for this distance from here to here. So I have this right triangle that I drew. Now I just need to find this missing length right here. Again, check your answer at the bottom of the page. If you've got it correct, you can move on to the next slide. So this problem is a little bit trickier because, one, it's on dot paper, which that shouldn't scare us, but it's asking us to find the perimeter, not just a side length. So we're going to have a little bit more math that we need to do here. I'm going to go ahead and help you with A, and then B, you're going to be on your own. So this dot paper, this centimeter dot paper, okay, they told us that each dot's 1 centimeter apart, so that means that this length right here is 2. And then likewise, this length right here is 2. And a lot of people want to say that this length right here is 2, but it's not. See how this from here to here is longer than, one of these lengths right here. So we can't just say that this is 2. So we actually need to find that length right there. So if we look, I have this right triangle. I have a leg here, so I'm looking for the hypotenuse. So I'd have 2 squared plus 2 squared, which is 4, plus 4, which is 8, which means the side length that I'm missing right here is the square root of 8, which is approximately 2.8. So then to find the perimeter is the distance around it. So I have a length here of 2.8 plus 2 plus 2. So 2.8 plus 2 plus 2 is 6.8 centimeters. And I see that answer at the bottom of the page. So I'm going to go ahead and cross it out. So now using what we looked at for part A, you go ahead and try part B. So one thing tricky about this problem is it does not give us a drawing, but it's essentially the exact same as number 3 that we did, where we have to draw the vertical line and then the horizontal line. And I know that I'm going to have one of those because I have a walks north and walks east. So you're going to want to go ahead and make your right triangle and fill in the values that you know, and then it's asking for this straight line distance from here to here. So when you get your answer, make sure that you check for it at the bottom of the page and cross it out before you move on to the next problem. This problem, you're going to need to draw the baseball diamond. Okay, so if I draw a baseball diamond, bear with me, I am not an artist. Here's my baseball diamond. And let's see, we know that the bases are 60 apart, so 60, 60, 60, 60. And then I want to know how far it is from home, which is right here, to second base, which is right there. So here's that nice, pretty right triangle that we have. So you're looking for this length right here. When you're done, check your answer at the bottom and cross it out. So make sure you read this question carefully. We have a diagram drawn for us, which is nice. But what we're looking for is how much shorter is the walk when we walk diagonally across the park. So if we walk diagonally across the park, that is this direction, okay? And many of you are going to find this length here and realize that the answer is not down at the bottom of the page because the question is asking me again, how much shorter? So you would need to figure out how far it would be to walk along here. So the 1.5 miles plus 2 miles to walk along the outside, which is 3.5. And then you need to figure out what this length is right here and figure out how much shorter it is. Okay, and then you should find that answer at the bottom of the page. When you get to the back of the page, you'll see there are just triangles for regular practice, but the only thing that you might see different are some side lengths that have square root numbers on the outside, which is not difficult. We just need to know how to work with them. So again, just like the warm-up, are we looking for a hypotenuse or a leg? Well, here's the hypotenuse. We don't know that. So we are looking for the hypotenuse. So then I would have 3 squared plus the square root of 7 squared, okay? Now, 3 squared, that's easy. That's 9. Now, the square root of 7 squared, let's kind of come over here and think about that for a second. Okay, so the square root of 7 times the square root of 7. What would that be? Okay, that would just be 7. Okay, so the square root of square root and squaring, those are opposites. Those are inverse operations. They undo each other, just like multiplication and division undo each other, or addition and subtraction undo each other. Square rooting and squaring undo each other. So that would just be 9 plus 7, which is 16, square root, and it's 4.